You know, you've definitely seen those viral videos, the ones where a highly advanced humanoid robot just casually does a flawless backflip off a platform.
Right, or it's like picking up some massive automotive part and just placing it perfectly on an assembly line.
Exactly. And when you watch that, it really feels like this miracle of software. You think, I'm looking at this hyper-intelligent digital brain that has somehow learned to pilot a metal body.
Which is, I mean, that's exactly the intended illusion. The companies building those robots, they want you focused on that fluid motion, the branding.
Yeah.
They definitely do not want you thinking about the incredibly fragile, just wildly complex physical supply chain that makes that motion even possible.
And that is exactly what we are dismantling for you today. So welcome to the deep dive.
Glad to be here.
Today, we are acting as, well, technological detectives. We have this really fascinating stack of sources to go through. It's an investor's highly technical personal notes, alongside 2 specific press release snippets about major tech collaborations.
That's a great stack of information.
Right. And our mission here is to decode this information and basically map out the hidden multi-layered hardware supply chain that serves as the eyes for these advanced robots.
Yeah, and this is such a crucial exercise for anyone trying to understand the future of tech.
Because we hear about physical AI all the time.
Exactly. We talk about physical AI constantly, but the magic there isn't just, floating in the ether.
Right.
It's not just billions of parameters of code. It is bound by the laws of physics. It's built on this really tangible, interconnected, and honestly obscure hardware foundation.
Which brings me to this analogy I like to use. It's like a Russian nesting doll.
Okay, I like that.
Yeah, so when you see that robot doing a backflip, you're just looking at the outermost doll. Today, we're opening it up layer by layer to find the tiny piece of tech at the very center.
The piece that actually makes the whole thing work.
Exactly. So let's start at the surface, the face of the operation. In our sources, the most recognizable piece of this puzzle is the Atlas robot from Boston Dynamics.
Right, Atlas is basically the celebrity of the robotics world.
For sure. But our first source is this image snippet highlighting a major development. Boston Dynamics and LG Innotek have entered into a new collaboration to introduce what they call next-generation vision systems into Atlas.
And just for context, LG Innotek is massive. They are a huge entity in the global components market.
Like phone cameras, right?
Exactly. They manufacture camera modules for some of the biggest smartphones in the world. They operate at a completely mind-boggling scale.
Which is why our second source is so curious. It's another snippet that notes LG Innotek is already a key player in optical and LiDAR sensing modules,
Right.
specifically targeting next-generation humanoid robots. So let me just play this skeptic here for a second.
Go for it.
Okay, let's unpack this. LG has billions in R&D. They are already established in optical sensors. If humanoids are the future, why wouldn't a giant like LG just build this next-generation system entirely in-house?
That's the million-dollar question.
Right. Like, what is fundamentally different about vision for humanoids that forces a behemoth to seek out new, specialized partnerships?
What's fascinating here is that it comes down to a massive leap in spatial complexity.
Okay.
Building a perception system for humanoids is an entirely different physics problem than, say, building a camera for a phone.
Or even an industrial robot arm.
Exactly. An industrial arm is bolted to the floor. Its universe is like a 3-foot radius of highly controlled space.
Yeah, that makes sense.
And even a self-driving car, which is complex, operates mostly on a 2D plane. It's a flat road with pretty predictable rules.
Right. A car isn't trying to reach into a chaotic kitchen cabinet to grab a coffee mug while balancing on one leg.
Exactly. A humanoid robot operates in 3-dimensional, totally unstructured space. It has to balance its own weight, it has to reach, and it has to instantly understand the depth and texture of everything around it.
And a velocity of things moving around it, right?
Yes. That leap requires perception systems so advanced that even an industry titan like LG cannot single-handedly engineer every single subcomponent.
So they have to look outside.
Right. They have to become the integrator. They have to seek out these highly specialized niche tech companies to invent the underlying mechanisms.
Which perfectly transitions us into the first hidden layer of our supply chain. And this is where we get into the investor's notes.
The really technical stuff.
Oh yeah, it gets deep. So the notes introduce a company with the ticker symbol AEVA, AEVA.
Right.
The investor reveals that LG poured a massive $50 million investment into AEVA to co-develop, quote, FMCW 4D LiDAR, unquote.
And humanoids are explicitly cited as the primary target there.
Yes. So here's where it gets really interesting. The investor's underlying thesis is that AEVA represents a long position, like a long-term hold for what they call 4D physical AI plus world models.
Which is a heavy phrase.
Very. But before we define that, I want to use an analogy for the listener.
Okay, lay it on me.
If LG is the optic nerve and the visual cortex, the massive infrastructure connecting the eye to the brain, then AEVA is designing the complex retina.
Oh, I like that. They're building the module that actually catches and processes the light.
Exactly. But we need to decode this retina. The text mentions FMCW 4D LiDAR. We all know 3D means spatial mapping. But what is the fourth dimension here?
The fourth dimension is instantaneous velocity.
Okay, explain that.
So, to understand why this is revolutionary, you have to look at traditional 3D LiDAR. Traditional LiDAR relies on something called time of flight.
Which means?
It shoots out a pulse of laser light, waits for that light to bounce off an object and return, and then times the journey.
Sort of like a bat using echolocation, but with light.
Exactly. It's an optical echo. It gives the robot a highly detailed, static 3D topographical map.
But the real world isn't static. I mean, if a robot is in a factory, forklifts are moving, people are walking.
And that is the huge flaw of standard time of flight LiDAR.
Oh, because it only captures still frames.
Right. To figure out if a forklift is moving toward it, the robot has to send out one pulse, get a 3D map, wait a fraction of a second, send out another pulse, get a second map.
And then compute the difference.
Yes. It calculates the difference between those frames to guess the speed. It takes massive computational power, and worse, there is latency, a delay.
A delay you literally cannot afford if a 200-pound robot is trying not to step on a person.
Exactly.
So how does FMCW change that physics equation?
So FMCW stands for Frequency Modulated Continuous Wave. Instead of shooting out stuttering pulses of light, it emits a continuous, uninterrupted beam.
Like a constant laser pointer.
Basically. And because the wave is continuous, it leverages the Doppler effect.
Oh, like how the pitch of an ambulance siren changes as it drives past you?
That is the exact mechanism, but with light instead of sound.
Wow.
Yeah, when that continuous beam bounces off a moving object, the frequency of the light wave actually compresses or stretches depending on whether the object is moving toward the sensor or away from it.
So the IKEMA sensor reads that microscopic shift.
Yes, it reads that shift in the frequency and instantly knows the exact speed and trajectory of every single pixel in its field of view. No calculating between frames.
That is wild. It perceives motion instantaneously,
Oh, yeah.
which actually makes total sense when you look at the second half of the investor's phrase, the 4D physical AI plus world models part.
Exactly.
Because if a robot has a world model, it means its AI has an internal, intuitive understanding of physics, right? Like if I toss a ball in the air, my human brain knows gravity will pull it down. I just move my hand to catch it.
Right, your brain has a built-in world model. But a digital brain cannot build an accurate world model if its eyes are just feeding it a slideshow of static 3D photos.
It needs the real-time velocity data.
It needs that four-dimensional data. It needs to know not just where a human arm is, but the exact velocity of that swing, so it can anticipate where the arm will be 2 seconds in the future.
Okay, but here is where we hit the absolute bedrock of the supply chain. We have LG integrating the eye. We have AEVA designing this amazing 4D FMCW module. But FMCW requires an incredibly specific type of physical light. Continuous wave lasers. And LG doesn't make those.
No, they don't.
AEVA designs the module, but they need someone to actually manufacture the physical laser emitters at scale. Going back to our analogy, we need the literal rods and cones.
Which brings us to the deepest, most technical layer of the investor's notes. The investor actually asks this in the text. Guess who makes those CW lasers for FMCW LiDAR?
And the answer they provide is a company with the ticker symbol SIV. S-I-V-E.
Yes, SIV.
But the investor doesn't just guess this. They justify it with a string of tech jargon that, frankly, sounds like an alien language.
It really does.
Let me just read this exact quote for you because we have to decode it. The investor says SV is, quote, the very same company for scaling photonics with 1.6T plus pluggables with JBL to CPO in MRVL Celestial, unquote.
Yeah, it is incredibly dense.
I mean, what does that all mean? For our listener trying to wrap their head around this, is the investor just looking at extreme plumbing of light technology to predict the future?
Basically, yes. Decoding that jargon reveals why this investor believes SBU is the absolute linchpin of the whole humanoid market.
Okay, let's break it down. Start with scaling photonics with 1.6T plus pluggables. What on earth is a pluggable, and what is 1.6T?
Okay, so think about massive data centers. The place is running cloud computing and AI training. Data is moving at incomprehensible speeds.
Right.
1.6T refers to transceivers capable of moving 1.6 terabits of data per second.
That's incredibly
That's
fast.
massive. And a pluggable is just the hardware module that plugs into the server racks to actually transmit that data.
Okay, but how does that relate to lasers? Weren't servers just connected by copper wires?
Historically, yes. But copper gets incredibly hot, and electricity faces physical limits on how fast it can travel through metal before the signal degrades.
Oh, so they switched to light.
Exactly. They shifted to photonics. Instead of electrical signals, you send pulses of laser light over fiber optic cables. It is vastly faster and cooler.
And SB is making those modules.
Yes, SIVE has proven to manufacture these photonics modules at that extreme edge of 1.6 terabits per second.
Okay, that explains the first part, but the quote continues. With JBL to CPO in MRVL Celestial.
Right.
Now, JBL is JetBill, which is a massive contract manufacturer, and MRVL is Marvell, a top custom chip designer. So SIVE is playing in the major leagues, but what is CPO?
CPO stands for co-packaged optics. This is basically the holy grail of hardware engineering right now.
Really? Why?
Because even with fiber optics, you traditionally have the silicon computer chip in one place and the laser optics at the edge of the board connected by a tiny wire.
Right, that makes sense.
But at AI speeds, even that tiny fraction of an inch of electrical wire creates a bottleneck and generates too much heat.
Oh, wow. Just a fraction of an inch.
Yes. So co-packaged optics means literally engineering the microscopic lasers and the glass directly onto the same silicon substrate as the processor chip.
You are fusing the light source directly to the brainstem.
Exactly. And combining standard silicon manufacturing with delicate optical lasers without melting the components or misaligning the light beams by a fraction of a nanometer.
That sounds impossible.
It's a bleeding-edge manufacturing miracle.
Okay, so bringing this all back to the investor's logic, the investor is looking at the humanoid market, looking at AEVA's LiDAR, which needs these ultra-precise continuous wave lasers.
Right.
And they realize AEVA can't make them. So they look at the whole global tech landscape and ask, who has the proven ability to mass-produce silicon chips co-packaged with continuous wave lasers?
And the answer is the company already doing it at 1.6 terabit speeds for the biggest AI data centers in the world, SE.
Wow.
If we connect this to the bigger picture, the investor highlights a critical quote. Frontier sectors in 4D physical AI to photonics tend to overlap.
Because the underlying physics problem is exactly the same. Whether you are shooting laser light through a data center to train an AI, or shooting laser light out of a robot's eye to navigate a room, you need microscopic, perfectly engineered lasers fused to silicon.
The investor's mapping the physics. They realize the key to AI isn't just code written by software engineers.
Right. A massive language model is useless in the physical world if it's trapped in the dark.
Exactly. The true value is in the companies manufacturing the physical components that translate the world into data the AI can actually process.
That is just fascinating. This really brings our whole deep dive full circle. Let's lay out this blueprint clearly for you, the listener, tracing it from the absolute bedrock back up to the surface.
Let's do it.
It starts with SIVERS. They have the extreme manufacturing capability to produce continuous wave lasers. They supply those fundamental light emitters to AEVA.
Right.
Then AEVA engineers those lasers into complex FMCW 4D LiDAR modules, creating a sensor that instantly maps 3D space and velocity. Then, AEVA partners with the manufacturing giant LG Innotek. LG takes those raw modules, integrates them into robust next-generation vision systems.
And finally, LG supplies those completed systems to Boston Dynamics, who installs them into the head of the Atlas robot.
SA to AEVA to LG to Boston Dynamics. And the investor specifically noted they took long positions in both ESI and AEVA based on this exact thesis.
Which is brilliant. Instead of just betting on the company making the famous robot, they traced the physics down to the bottleneck and invested in the foundational layers.
And that is the shift in perspective we promised you. The next time you are scrolling through your feed and you see a Boston Dynamics robot navigating a complex warehouse floor,
Catching a thrown object, stepping around a moving forklift.
exactly, you won't just see a shiny metal shell anymore. You will see a triumph of highly specialized, incredibly fragile supply chains.
Because behind that fluid movement is a direct line from C's co-packaged optics to AEVA's continuous wave LiDAR to LG's integration.
This really forces you to look past the software and the branding, doesn't it?
It has to. Understanding this specific map changes how we should evaluate the whole AI and robotics industry, We shouldn't just look at who writes the algorithms. We must look at who handles the physics of light.
Because the entities that control the perception of the AI control the potential of the AI.
Absolutely.
Well, we started today talking about a viral video, and we've tunneled all the way down to the atomic level of silicon and lasers. We've essentially mapped out the anatomy of artificial sight. So thank you for joining us today and for acting as our fellow detective as we went deep down the rabbit hole with these sources.
Yeah, uncovering the nuts and bolts of tomorrow's tech requires digging through a lot of complex layers, but the clarity you gain at the bottom is always worth it.
Definitely. But before we let you go, we want to leave you with a final thought to chew on, something that builds directly on this incredible specialization we've uncovered today.
It's a slightly unsettling thought, honestly.
It really is. If the eyes and the world models of our next generation humanoid robots are so entirely dependent on this incredibly narrow overlapping chain of photonics companies, what happens if there is a bottleneck at the very bottom of that chain?
Right. What if that tiny link breaks?
Are our future robotic companions inherently fragile? Not because their AI brains are flawed, but because the incredible scarcity of the hardware required to give them sight relies on manufacturing miracles only a handful of facilities on Earth can achieve. It really makes you think about the sheer physical vulnerability of our digital future. Until next time.